Okay, in this video we're just working on a few exercises from 3.3. Exercises from 3.3. And so the first one, let me go ahead and write it down. I'll pause. Okay, so this differential equation is going to be y double prime. This is number 17 from 3.3. Y double prime plus 4y equals 0, with y of 0 equals 0, y prime of 0 equals 1. Okay, and as with all these differential equations, the very first thing we do is to write down the characteristic equation and solve. So in this case we have r squared plus 4 is equal to 0, and so therefore r is equal to, let's see, I'm going to have minus 4, so that's going to be the square root of minus 4, so that'll be plus or minus 2i, right? And notice that this is pure imaginary, so the alpha equals 0 here, right? And so therefore my solution, my general solution is going to be c1 cosine of 2t plus c2 sine of 2t. Okay, and now we just have to find our initial conditions. So as a note here, right, I'm going to go ahead and write y prime of t. That's going to be, let's see, minus 2 c1 sine of 2t plus 2c2 cosine of 2t. I seem to be writing crooked tonight. Okay, y of 0 equals 0 means that 0 will be c1 times 0 plus 0, right? C1 times 1 plus c2 times 0, and so c1 is going to be equal to 0. Okay, well, that makes life a little easier. How about y prime? Y prime of 0 equals 1. So what's that going to be? 2c2 is equal to 1, and so therefore c2 is equal to 1/2. Good. And so we see that our y is just going to be 1/2 cosine of 2t. Oops, c2 is so that's the sine function, right? Sorry about that. And just for the sake of argument, what does this look like? This is just going to have a regular sine wave, right? And the amplitude is going to be 1/2. Notice that I write down the wave before I put down the numbers, and so the full wave here is going to take 2 pi over 2 as pi units, and so that'll be pi over 2. This is very symmetric. Good. Good, and so that's what the waveform is going to look like. All right, and it'll just keep oscillating forever. Good. Okay, I'll write down the next one and pause in between. Okay, so I'm taking a look at number 23 in the book, 3u double prime minus u prime plus 2u equals 0, where we have u of 0 equals 2 and u prime of 0 equals 0. And first we'll want to find u of t, the solution, and secondly we'll try to find t such that the magnitude of u of t is equal to 10 for the first time. Okay, so let's give it a try. First thing is just to go ahead and write down our characteristic equation. Okay, and then with the 3 in the front, right, it's not going to factor quite as nicely. You know, if you wanted to complete the square, you would say 3 times r squared minus 1/3 r, right? And then we could put the negative 2 on the other side. And then half the middle term squared is what we would put in here. So that's going to be 1/36. Okay, but notice that we're adding not 1/36, but 3/36 in here. And so we could simplify that, or we could just go ahead and write it as 3/36 on the other side. Okay, and now this is going to be 3 times r minus 1/6 squared, right? And so let's get out our calculator. Okay, it was just taking a minute to do a few computations here. So simplify that. I guess I should have simplified that first. Then go ahead and write minus 2 is minus 24/12. That'll give us a minus 23 over 12. And so therefore we get minus, let's go ahead and take out the 3, minus 23 over 36. And so then r is going to be, can we solve for that? That'll be plus or minus the square root of 23i over 6, right? 1/6. And so in this case, it probably didn't really, we didn't really save very much time from just going ahead and using the Pythagorean theorem. It's not the Pythagorean theorem. I was thinking of a different problem. Quadratic formula. In that case, right, we would have b squared, or minus b plus or minus the square root of b squared minus 4 ac divided by 2a, and you already see our 1/6 there. And okay, so we didn't save any time there really for that one. Okay, but we do have our r values now, and so we know what our u of t is. So I know our u of t is going to be e to the t over 6 times c1 cosine of the square root of 23 over 6 t plus c2 sine square root of 23 over 6t. Okay. Now notice when we're taking the derivative, it's going to be a little bit of a mess. So I'm going to do some abbreviations here as I do that. U prime is going to be 1/6, right? E to the t over 6 times c1 cosine plus c2 sine, right? And then I'm going to have plus e to the t over 6 times, and I'm going to have the square root of 23 over 6. Oh, that'll be a minus c1, and then that'll be a sine something something. I'm trying to abbreviate because this is getting messy. And then we'll have our square root of 23 over 6 cosine. Okay, so now what happens when if I put in u of 0? U of 0 is going to be e to the 0 power. This cosine of 0 is going to be 1, so that's just going to be c1. That's going to be c2 times 0, so that's just c1. So c1 is equal to 2. Good, that was easy. Now u prime of 0 is going to be what? If I plug in 0, I'm going to have 1/6, right, times c1. c1 was 2, so I'm going to go ahead and put a 2 in there, 2 plus 0, right? Plus, and then we'll have an e to the 0, which is just 1, times the sine of 0 is 0, so that's going to be 0's square root of 23 over 6 times our c2, right? And that's it. So therefore, this, we want that to be equal to 0. Can we solve that for c2? Am I running out of space? So it looks like we've got 1/3. So square root of 23 over 6, c2 is equal to minus 1/3. Let's see, multiply both sides by 6 would give me minus 2 over square root of 23. Good. Now I've got my c1 and my c2. I can put it in here and find my u of t. Good. Now, the second part is going to be a little bit awkward because we're going to have to use the computer to solve for that. And so in the next video, I'm going to go to Wolfram Alpha and solve it there. Okay, so join me in Wolfram Alpha in the next video.